All right, let's give Webassign 2 a try. Let's get a little bit closer here. That way we can see what's going on. Okay, so this one is homework help for momentum number 2. All right, let's take a peek. Okay, so our first one here, tennis player receives the ball, traveling horizontally, returns the shot in the opposite direction. Okay, again, direction is important because you're gonna end up with some double negatives there. Impulse. Ft is my impulse, right? So really all I need to do is mass times delta V. But again, direction's important. So make sure you watch out for those double negatives. What work does the racket do on the ball? Keep in mind that while you might know force, you don't necessarily know distance, and that might be your first impulse there. Haha, pun, Smith, are you laughing? Anyway, that might be your first thought, but you don't have the distance, so it's kind of like, well, what do I do there? What you have to remember is that the work being done is simply changing the kinetic energy of the ball. This is actually kind of a handy little relationship that comes up every once in a while. It's called the work kinetic energy theorem. So again, any sort of change is final minus initial. So make sure you work with it that way and you can solve for the amount of work. Okay, on to number 2. Number 2 is where we have to do our first round into calculus here. You're given a function for the force, and look, our very first question is looking for impulse. So what you need to do is take the integral of that force function with respect to time, and that will give you the impulse. Okay, and after that you can evaluate from 0 to 0.8. So just remember that when you are doing that, when you actually are evaluating that sort of thing, that what you are going to want to do, oh, there we go. I'm saying I lost track of what I was doing here. Once you actually evaluate that, you're going to get a function, obviously, when you take the integral, but first you're going to put in the 0.8 for time, and then you're going to subtract, now let's say that the impulse at 0.8, and you're going to then subtract the impulse at 0, and then that will be your final answer for the impulse. Okay? With what speed does she reach the platform? That's simple energy conservation. All right, potential energy becoming kinetic. That shouldn't be too tough. With what speed does she leave it? This one is tougher than you think, or at least I should say I see common mistakes on this one every single year. Okay, realize that it's not just a matter of a rebound here. The platform and gravity, that's the part everybody forgets, are actually providing an impulse to change, what is it, this person? Yeah, it's an athlete, to change the velocity of the person. So what you have to consider is that there's an impulse being given by gravity, the force of gravity, that is, right, plus the impulse from the platform. Sorry, I'm like squashed, which is, oh, sorry, I'm off the page here. That is going to equal the change in momentum, which is our, oh no, my little clamp is moving. Sorry, I'm sitting at my desk. I've got like these chemistry clamps that I hijacked to do this, and it just started going all by itself. What is that? All right, so remember then this is mass times delta velocity, so you really, ultimately you're solving here for final velocity. But don't forget the impulse caused by gravity going downward, okay? To what height did she jump upon leaving the platform? Once the impulse part is finished and you have all that kinetic energy at the bottom, right, because you'll know the new final velocity, then of course that can translate into potential. So that's actually not too tough. It's just that middle that gets a little bit wonky, okay? All right, last one on this homework. Railroad car. Okay, so what you've got here is, obviously it's a conservation of momentum question. Remember that you are going to collide and couple with the other 3 cars. Let me move this so we can actually fold it up and work here a little bit. So if you do that, remember that your mass is going to be 4 times what the original railroad car was. Okay, and obviously the first car has momentum, but cars 2 through 4 have 0 initial momentum. And then you're going to have the momentum for cars 1 through 4. and they're going to move with the same velocity at the end. Okay? How much energy is transformed into internal energy? This does not conserve kinetic energy, but the idea here, of course, is that you would find both of those kinetic energies and then subtract them. All right? The difference is going to be the loss of that kinetic energy. Okay, hopefully that helps out, and talk to you soon.